There's a wealth of knowledge we've accumulated about the universe, ranging from the intricate structures of star systems to the mysterious phenomena of dark matter and dark energy. Over several decades, research efforts and meticulous observations have contributed to unraveling the intricate tapestry of cosmic evolution. Yet, amidst this vast expanse of knowledge, a recent revelation courtesy of the James Webb Telescope has sent shockwaves through the scientific community. This discovery stands to challenge the very foundations of our understanding of the universe's evolution, unsettling even the most fundamental principles of physics. What exactly has been unearthed, and why does it carry such profound implications? How does this discovery reverberate across our cosmic model and the scientific landscape? Join us as we delve into the implications of the James Webb Telescope's latest image, which has thrust our cosmological understanding into uncertainty. The pursuit of comprehending the universe's evolution has been an enduring quest for humanity, driven by an innate curiosity about the origins and intricacies of the cosmos. This insatiable thirst for knowledge has birthed disciplines such as astronomy and cosmology, serving as beacons illuminating the mysteries of the cosmos. Through these avenues of exploration, we've gleaned profound insights into the vast expanse of space and its myriad wonders. One such revelation pertains to the heterogeneous distribution of matter within the universe. Certain regions exhibit greater density than others. This observation lends credence to the Big Bang theory, which posits that the universe originated from a singular, infinitely dense point before undergoing rapid expansion. Evidence such as the cosmic microwave background, a relic of the universe's infancy, provides compelling support for this cosmological framework. Theories elucidating the universe's evolution have undergone iterative refinement over time, propelled by advancements in observational technology and theoretical frameworks. However, the pursuit of cosmic understanding occasionally encounters enigmatic anomalies that defy conventional explanation. The recent discovery facilitated by the James Webb Telescope exemplifies such an anomaly. The James Webb Telescope stands as a testament to human ingenuity, representing a paradigm shift in 21st century cosmological inquiry. Equipped with cutting-edge technology, this revolutionary instrument affords unprecedented clarity in peering into the depths of space, transcending the confines of our planetary boundaries. Its primary objective encompasses the observation of the farthest reaches of the cosmos, endeavoring to unveil the secrets concealed within the celestial tapestry. By scrutinizing celestial bodies formed in the wake of the Big Bang, scientists aim to glean insights into the universe's formative epochs and refine our understanding of cosmic evolution. In addition to facilitating observations of celestial phenomena, the James Webb Telescope has catalyzed breakthroughs in our comprehension of elusive concepts such as dark matter and dark energy, which underpin the scaffolding of the Big Bang theory. Dark energy, believed to be the driving force behind the universe's accelerated expansion, remains a subject of intense scrutiny and speculation. Concurrently, dark matter, an enigmatic form of matter that eludes direct detection, exerts gravitational influence on cosmic structures, shaping the cosmic landscape. Gravitational lensing, a phenomenon elucidated by Einstein's theory of general relativity, emerges as a pivotal tool in probing the distribution of dark matter within the cosmos. As massive celestial objects warp the fabric of space-time, light traversing these gravitational gradients undergoes deflection, manifesting as distortions in observed images. Through meticulous analysis of gravitational lensing effects within James Webb Telescope imagery, scientists endeavor to construct detailed maps delineating the spatial distribution of dark matter. In summary, the James Webb Telescope stands as an indispensable asset in humanity's quest to unravel the mysteries of the cosmos. Its unparalleled capabilities have not only reshaped our understanding of cosmic phenomena, but have also bestowed upon us breathtaking vistas of distant stars and galaxies, igniting the imagination and driving the relentless pursuit of cosmic enlightenment. Despite its monumental contributions to the scientific community, the James Webb Telescope continues to forge ahead, unveiling a series of remarkable discoveries. Among these, one stands out prominently: the revelation of planet-like objects nestled within the Orion Nebula, situated within the Milky Way galaxy. The Orion Nebula has long captivated astronomers' imaginations, portrayed as the illustrious sword in the Orion constellation. Previous examinations of this cosmic cloud, composed of dust and gas, had failed to unveil any discernible objects concealed within its depths. However, with the advent of the James Webb Telescope, this narrative underwent a profound shift. The telescope's cutting-edge capabilities facilitated the detection of these celestial anomalies, marking a watershed moment in our exploration of the cosmos. Yet, amidst the triumphs of discovery, a disquieting revelation emerged, one that threatens to upend our foundational understanding of cosmology and astronomy. Recent observations captured by the James Webb Telescope have brought to light a staggering phenomenon: an unprecedented disappearance of over 771 trillion solar systems from the fabric of our universe. This abrupt vanishing encompasses not merely stars but also their attendant retinues of orbiting planets. Such an occurrence defies conventional astronomical precedent and contravenes one of the bedrock principles of physics, the law of conservation of matter. According to this immutable law, mass can neither be created nor destroyed. It can only undergo transformation between different forms. Given the foundational reliance of cosmological inquiry on such principles, the enigma surrounding the disappearance of these solar systems poses a profound challenge to our current understanding of the universe. In the wake of this baffling event, scientists grapple with a myriad of conjectures in their quest for elucidation. One hypothesis posits that the vanished solar systems may have undergone a transformative metamorphosis akin to the life cycle of aging stars, culminating in supernova explosions. In this scenario, the remnants of these celestial entities persist in alternate forms within the cosmic tapestry, evading detection by conventional means. However, skepticism abounds regarding the plausibility of such a scenario, as the absence of supernova signatures belies the scale of the purported transformation. Alternatively, attention has turned towards the formidable entities known as black holes, whose voracious gravitational appetites are capable of engulfing entire stars. While black holes have been observed devouring celestial bodies on a smaller scale, the sheer magnitude of the vanishing solar systems challenges the feasibility of such an explanation. The notion that individual black holes could account for the disappearance of trillions of stars strains credulity, necessitating a more nuanced exploration of cosmic dynamics. In response to this perplexing conundrum, a pioneering initiative spearheaded by Dr. Beatrick V. Roll of the Northern Institute for Theoretical Physics in Sweden has emerged, the VASCO project. This endeavor seeks to scour astronomical archives in search of historical precedents for celestial disappearances akin to the contemporary phenomenon. By identifying instances of stars vanishing from the celestial canvas, researchers aim to glean insights into the underlying mechanisms driving these enigmatic occurrences. Despite the absence of definitive findings thus far, the VASCO project has galvanized the astronomical community, sparking fervent discourse and speculation across diverse scientific disciplines. Nevertheless, the quest for understanding remains fraught with uncertainty as researchers confront the vastness of the cosmos and the limitations of human observation. While the VASCO project holds promise as a potential avenue for unraveling the mystery, the absence of tangible evidence underscores the profound intricacies of cosmic phenomena. As astronomers and astrophysicists continue to probe the frontiers of the unknown, the tantalizing enigma of the vanished solar systems stands as a testament to the enduring mysteries that beckon humanity's relentless pursuit of knowledge amidst the cosmos. Dr. R. and her team remain steadfast in their commitment to the VASCO project, refusing to relinquish hope. They entertain the possibility that a celestial disappearance may have occurred unnoticed, concealed within the vast expanse of the cosmos. Moreover, astronomer Lou Aravi has advanced a provocative proposition, suggesting that certain stars possess the capacity to bypass the conventional trajectory of stellar evolution, transitioning directly from their waning phase to the state of black holes. Aravi cites a notable incident in 2019, where a star identified as nearing the end of its life cycle underwent a sudden and cataclysmic transformation into a black hole. The rapidity of this metamorphosis precluded detailed observation, leaving scientists grasping for insights into this enigmatic phenomenon. Could a similar scenario be unfolding amidst the current conundrum? Nevertheless, data gleaned from the James Webb Telescope belies the hypothesis of black hole transmutation as the sole explanation for the vanished solar systems. the absence of black hole signatures within the observed regions suggests an alternative avenue for inquiry. Some voices within the scientific community posit that a potential flaw or malfunction in the James Webb Telescope may underlie the perplexing disappearance of stars. Perhaps the telescope's infrared cameras, designed to detect distant objects by capturing their infrared emissions, encountered operational impediments, rendering the vanished stars imperceptible to its sensors. However, NASA's diligent scrutiny has thus far failed to unearth any anomaly within the James Webb Telescope's instrumentation. Consequently, the focus shifts back to the stars themselves as potential sources of the observed discrepancies. The theory that the vanished stars may have undergone diminution or spectral shift offers a compelling avenue for investigation. If these stars have dimmed or transitioned to wavelengths beyond the infrared spectrum, their luminosity may have eluded detection by the James Webb Telescope. Yet, despite the plausibility of such explanations, none singularly proves comprehensive enough to fully elucidate the mystery at hand. In the absence of a definitive solution, some members of the scientific community have ventured into the realm of speculation, broaching the contentious notion of extraterrestrial involvement. Could the sudden disappearance of these star systems be attributed to the machinations of advanced cosmic civilizations? The discourse surrounding extraterrestrial activity has pervaded scientific circles for decades, fueled by intermittent sightings of unidentified aerial phenomena and unidentified flying objects. Recent disclosures, such as the U.S. Congress hearing in July 2023 and the Mexican Congress hearing in September 2023, have injected renewed vigor into the debate, providing tantalizing glimpses into the potential reality of extraterrestrial encounters. Nevertheless, skepticism persists, rooted in the absence of irrefutable evidence substantiating the existence of extraterrestrial beings. The notion that advanced alien civilizations could orchestrate the disappearance of entire star systems remains speculative, reliant upon conjecture rather than empirical observation. Yet proponents of this theory posit that such civilizations may possess technology far beyond our comprehension, capable of harnessing stellar energies for their own purposes. One hypothetical mechanism proposed by proponents of the extraterrestrial theory is the construction of Dyson spheres, a speculative megastructure encompassing a star to capture its energy output. By harnessing the boundless power of a star, advanced civilizations could exponentially augment their technological prowess and sustain their societal infrastructure. While the notion of Dyson spheres remains firmly ensconced within the realm of speculative fiction, its invocation underscores the boundless imaginative scope of cosmic inquiry. In summary, the enigma of the vanished stars persists as an enduring testament to the vastness of cosmic mysteries and the inexhaustible curiosity of the scientific community. Whether rooted in natural phenomena, technological aberration, or the machinations of advanced civilizations, the quest for understanding continues unabated, propelling humanity ever closer to unlocking the secrets of the cosmos. Indeed, while the concept of Dyson spheres remains within the realm of scientific plausibility, the existence of extraterrestrial civilizations remains speculative. Moreover, the feasibility of harnessing the energy output of 771 trillion stars simultaneously necessitates the existence of an exceedingly vast number of advanced civilizations, a conjecture that strains credulity. Consequently, the extraterrestrial hypothesis fails to provide a satisfactory explanation for the mysterious disappearance of these stars, leaving scientists grappling with an unresolved enigma. Amidst this perplexity, the James Webb Telescope has unveiled another disconcerting revelation, an anomaly lurking within the distant void of the universe. Within the confines of the spiral galaxy NGC 5584, located approximately 75 million light-years away, pulsating stars have been observed encircling a central focal point. These pulsating stars defy conventional cosmological expectations, challenging our understanding of the universe's dynamics. This discovery suggests that the universe may be expanding at a rate surpassing the predictions of prevailing cosmological models, thereby conflicting with the established framework encapsulated by the Hubble constant. The Hubble constant, named in honor of the pioneering astronomer Edwin Hubble, serves as a fundamental parameter in quantifying the rate of the universe's expansion. Edwin Hubble's groundbreaking observations, conducted with the aid of the world's largest telescopes, elucidated the linear relationship between the distances of galaxies and their velocities, thereby laying the groundwork for the formulation of the Hubble constant. Despite its significance, determining the precise value of the Hubble constant has proven elusive, precipitating a long-standing debate within the scientific community.